Okay, so continuing further with the ICMP request and reply messages, the first one under this category is echo request and reply. It is a type of request and reply message, and that means that you initiated the ICMP and you get back the ICMP. So what are the various advantages and disadvantages of echo request and reply, and where you could use it? So let us go into the echo request and echo reply message directly, and then we would be in a position to understand it more clearly. So ICMP works at the network layer. It will start from network layer of A and will reach till network layer of B during request, right? And during reply, what it will do, it will start from the network layer of B and will reach till network layer of A. So echo request and reply mechanism is used to check the network layer of destination is working or not, right? So we are checking whether the network layer at the destination is working or not, and all the networking devices on the way are also working properly or not. So indirectly, we are getting the benefit of checking all the internetworking devices and the destination machine. It is simply to check the host is switched on or not. In that way, with this ICMP, we can check that the host on the receiver is on or off. So B's application layer will never see the ICMP packet, right? Application layer, right? So because it is working at the network layer, right? So no one on the destination will be able to see that you are actually sending a packet. So it is at the network layer only. It is never going to reach at the application layer. So no one can see that. So because of this, there are various attacks which are possible. Now this is the disadvantage of this ICMP echo request and reply. One classic problem which is implemented using echo request and echo reply is ping. So whenever you ping, what is sent is echo request, and reply to it is echo reply. So that is how you can check the station is working or not. That is what we have seen, right? So internally, it is nothing but ping operation. What is ping is packet internet gopher. Packet internet gopher. What is the meaning of gopher? Gopher means we are searching in the dark. That means we don't know whether a station is there or not. So ping is not ping is not a client server application. It will just go to network layer of the destination and it will come back. So what you can do is, if there is a server and if you want to bring it down, you may send 1 lakh ping packets to it. And what will happen is that the hardware of the server, the destination, will be very busy answering to all the ping echo requests, right? Sending echo replies. So all the CPU, entire CPU will be consumed to only answer your echo requests. This is also called as ping attack, and it may lead to what? It may lead to denial of service. So that's DOS attack, DOS attack is also very popular terminology. Right. So next is this is all about the echo request and echo reply, and the ping is one of the utility which is there, and the disadvantage of that is attacks could be possible. Next is router solicitation. Now, what is the meaning of router solicitation? Is like to send a packet outside your network. To send a packet outside your network, you should send it to the router. So it is not just enough that you know your IP address, but you should also know who is the router connected to your network, right? So once you know the router, then you can start your communication. So now we should discover a router, right? So what will happen is there is a host A, let's say, and it has got its IP address. So how does it got its IP address? Is by broadcasting a packet from DHCP, and now it does not know who is the default router connected to the network. So it should know it, right? So for that reason, it will send out a ICMP packet. So it will send out a broadcast ICMP packet, which is also called as router solicitation, right? So router solicitation means please advise me if there are any routers in the network so that I could use it as a default router. Then all the routers, which are present in the network are supposed to reply to this station. Station A will then set this router as the default router or the default gateway. So station A, that's what it will do, right? There could be more. Now see, there could be more than one internet connections taken by a company, like one from Airtel, one from Reliance, and so on, right? So basically, the more than one internet connections are taken by a company because they want more reliability for their services, right? So there could be many routers connected to the network, and network stations. And when broadcast ICMP router solicitation message is sent, all the routers will reply, and only and any one router which the system will accept will be set as the default router or the default gateway. Anyone could be set as the default router. One more router will be set in between, so there is no second diagram which is there. One more router will be set in between, and that will be connected to all these other routers. So this is done basically for load balancing. If one of the network is in heavy load, then it can forward it to the other through the other routers. So you are not going to send packets all the packets via only one network. Right. So when three companies connections are there, reliability will definitely be improved. Why? Because if one service fails, the other will continue to provide the internet connection. So reliability of the service would be there. Right. So next is this is all about the router solicitation. Then there is router advertisement also. And before we go into the network mask, we should understand what is router solicitation and advertisement. So router advertisement means no one is asking for any router. Understand? No machine is asking for any router. But assume that a new router is connected to your network. Then this router is supposed to advertise to everyone in this network, saying that I am available, so that in case if any station wants it, it can use the router. Right. So it is like new router is added to the system, and it is saying to everyone that I'm available. And if anyone wants to use it, then I'm available for that. So they can set it as a default router. So both router solicitation and advertisement are used to set the default gateway, right? And continuing further with the other types of messages, there is one more message which is network mask request and reply. So now between there is a sender, there is a router, there is a receiver, right? And the network would be there. So you should find out what is your subnet mask. I mean, your station should know what is its subnet mask. So how do you get this subnet mask? So it's again from the router only, right? So once you find out who your default router is, then you will send a message to this default router asking for, please send me the network mask, right? So generally network mask will be present inside the router, and the network administrator is going to set it up for every machines which are present in the network. So network, when it is demanded for this subnet mask, it will provide that subnet mask to the stations. So what is the network mask for that network will be known. So once you find out your network mask, it is very easy for you to decide who are present in your network and who are not present in your network. Therefore, communication could be easy with the routers, right? So generally, we have networking devices placed at various parts of the world, and when all these devices are present in different time zones, then there will be a problem of synchronization, which means that two devices, if they want to maintain the same time, so that they can communicate and can see the messages consistently, then time synchronization is required to be done, right? So different time zones are there, and because of that, time synchronization is required. So in order to do that, there is a special type of ICMP message called as timestamp request and reply, right? And that means that at the source you are having at the source you are having, that means you can find out the time at the destination, and the destination can find out the time at the source, and they can synchronize the time. But then it is highly unreliable and not heavily used, right? This is highly unreliable, no synchronization and other things. So it was initially used long back, but at present, no, we are not using it. We have various good protocols like network time protocol, which are working fine. Right? We'll look into this different protocols little later when we cover those topics. So one of the application of ICMP we will discuss, that is Traceroute, right? So is a utility program, and which is given by every operating system. Now Windows will be having trace RT command, or maybe Unix Linux will be having traceroute, trace RT, so that you can just check it out on the system, and appropriately, different operating systems will have different versions of this type of command. So this utility. So traceroute, let's say www.google.com, and when it reaches google.com, what are the various routers which are coming in between? That is the objective to be fulfilled. So you are going to find out all the routers which are there between you and Google, right? So that is between the source and the destination, various routers will be there. So after finding the IP addresses of the routers, I mean, after finding the IP addresses of the router, maybe you can go to the website known as, let's say, Whois website, and then type this IP address there. And then what you can do is you can find out the location of this router where it is present. So you can find out that your packet is going to this many countries, let's say England, then US, Europe, Australia, and so on. So by this IPs, you can identify that where these routers are present, their locations, and so on. So this utility Traceroute is implemented using ICMP. So how is it done is, there is already a Traceroute, a record route option which is there in IP. But this record route is different compared to Traceroute, right? So that difference, that you should know. So record route, in record route, destination is going to find out which router comes in between, right? So which routers are going to come in between? That would be known in the record route option. But in Traceroute, the sender has to find out what are all the routers on the way between sender and destination, right? So how will the sender find out that router R1 is the router at the first hop? If router R1 sends back a source, it sends back something to the source saying that I am there at hop 1, then it is possible. So it has to have some such mechanism. At R2, we will send a message to R2, and R2 should send a message to source saying that I am there. Likewise, R3 should send a message to the source saying that I am there. But then how can we make sure that the routers will send you a message? Routers are very busy, and generally they don't implement intentionally such messages, right? So using the existing messages, you have to cheat them in such a way that they will be sending you a message back. So for that, we are going to use ICMP TTL exceed. So what we do is we create IP packet with source and destination, and we set TTL equal to 1 in the first case. So the router, in the first router for this packet, the TTL will decrement from 1 to 0, and what will happen is, and whenever TTL equal to 0, the packet will be discarded, right? So packet will be discarded, and you will get back the ICMP packet, right? On this ICMP packet, you will have the type as TTL exceed, and the router which has sent it, right? So a router R1 will initially send it when the TTL 1 becomes 0. So it will send the ICMP packet with TTL exceed, type as TTL exceed. So likewise, we'll set TTL equal to 2. So router R2 will reply, then TTL equal to 3. So R3 will reply, and TTL equal to 4. And when it becomes 0, so again it will reply. So but then whether it is reached the destination or not, that will be an issue. So can you say that R1, R2, R3 are on the way, and if you don't get the ICMP packet, it does not necessarily mean that no destination is reached. It might be the case that ICMP is lost. So that is most of the time ICMP will be generally be lost, understand. So when you don't get the ICMP packet, does not just assume that the destination is reached. If you don't get the ICMP packet, there are various cases. First is like ICMP itself is discarded on the way, and therefore we have to distinguish whether ICMP is lost or we have reached the destination. That both cases are possible. So what is the only way that destination host will send an ICMP packet? The destination port is unreachable, right? So that is one option which is there. So destination port unreachable. So that means that destination packet has reached the destination host, but by this destination port unreachable, we can assume that we can come to know, the source will come to know that actually the packet has reached the destination. So inside this IP packet, we put a TCP or UDP packet. Let's use let us normally what will happen is we'll use the UDP packet with a dummy port number. Then what happens is this packet is received by the destination. Destination is going to then take it, but then when it search for port number to deliver the packet, the port will not be reachable. Therefore, what will happen is even the destination will also send the ICMP packet. So on all ICMP packets, the message will not be only TTL exceed. The error message can be destination host unreachable. So these two will be used to by the source to identify whether the packet was successfully reached at the destination or not. So therefore, when the source gets this DHU, that the destination host unreachable message, so it is very sure that the destination is reached, and so we can stop the procedure in the trace route. So this is how Traceroute is implemented. It is not always guaranteed that you will get R1, R2, R3, R4. You may get R1, R2, timeout, R1 timeout, then R2, and so on. So in this way, various things would be there, and sometimes the Traceroute will not be even giving you the full path correctly. Understand? So Traceroute does not assure you that there will be a complete path available with you. So let's say the source is sending the packet to the destination. So all the routers put together, what will happen is the packet will go from will reach to the R1, then R1 will send it to R2, and maybe at that place if there is some discard, then it will reply and so on. So there is a possibility that R1, then R2, then it will at the third level it is R5, R6, and discard. I mean destination. So all the routers put together, it does not guarantee that the reply will be forming the appropriate path given to such situation. But then the chances are that that we are going to send the dummy packets in a fraction of time. Therefore, what will happen is the basic assumption is that the route will not change very fast dynamically. I mean, it will not change dynamically. That means that in 1 millisecond the route might not change, but there is no guarantee for any path, right? So how does it work? Is like it is like breadth first search sort of thing. Like in that any router at distance 1. So which are the routers at distance 1? Distance 1 is R1. So R1 is supposed to reply. So at any router at distance 2 routers are R2 and R3. So either these two routers can reply. And any router at distance 3, R4 and R5 are the two routers which can reply. And any router at distance 4, that is R6. So R6 can reply. So which means that we are going to have something like breadth-wise sort of mechanism, and it is not the actual path actually. So this is what I want to say, that the ICMP reply will not guarantee that the actual path would be available, right? So may not be, and this also once they even though if there is a path, this path will not change, right? So next in the category is the path MTU discovery message, right? Request and reply sort of thing. What is there inside this is the MTU is of 1500 byte, let's say at the source side. Then MTU at the intermediate network is let's say 300, 500, and the last one is having the MTU of 300, right? So 1500, 500, and 300. and when I send the first packet, let's say of 1500 and DF equal to 1, so port number for the destination, okay, we'll keep it on one side. Let's say only 1500 and DF equal to 1. So what will happen is, do not fragment equal to 1 flag is set to 1. So when it reaches to the router R1, no, it sees that no, the underlying the other MTU is 500 and the packet is of 1500. So this packet will not be will be discarded. This packet will be discarded, and it will be generating an ICMP reply message with all the information saying that destination unreachable, fragmentation required, DF equal to 1, MTU equal to 500. So now when the next packet is sent, so what it will do is, instead of now sending the packet of 1500, it will send the packet of 500, right? So then 500 packet size is sent with DF equal to 1. So the sender is sending it, so it will cross the first router, then pass through the network, and it will reach to the second router. Second router sees that no, okay, there is a MTU of 300 on the other side. So again, no, it will generate an ICMP packet, and will ICMP packet with the destination unreachable, fragmentation required, DF equal to 1, and MTU is equal to 300. So ICMP has to then to be reached to the source through the router. So now we know that the MTU is 300. So what we will do is, we will again send the packet with 300. The source will send the packet with the size of 300 and DF equal to 1. In that case, it will successfully be reaching, right? But then ICMP packet on the way might get lost. So again, no, what could be the possibility is that we will send the UDP packet to actually check whether the destination unreachable is there or not. Right, so we are sending just the UDP packet of size 300 within that, and DF equal to 1. So packet with dummy port number will be sent, and destination will generate then the ICMP reply packet. In that case, it will say that destination port unreachable. Instead of saying that destination host unreachable, it will say it is destination port unreachable. Right. So in this way, it will come to know that the path MTU discovery request and reply sort of thing is fulfilled, right? So this is all about the ICMP request and reply messages. We have seen completely the ICMP things, which are the concepts of ICMP, which are for error messages and for the request and reply sort of thing. Okay. So in the next remaining videos, we'll be looking into the other topics related to the networks. Okay. So I hope that you are able to understand this. Make sure that you read through this video, go through this video a couple of times, so that it becomes easy for you to understand. Right.